Hello everyone. So today we are going to solve GLG problem of the day, that is optimal strategy for a game. So you're given an integer array of size n. The array element represent n coins of value v1 till vn. So you have given an array. Each array element has some sort of value. You play against an opponent in an alternating way. So like first I will play, then the next guy will play, then again I will play. In each turn, a player selects either the first or last coin from the row and remove it from the row permanently and receives the coins value. So from the entire array, either he can take the first value or the last value, and whatever value he took, it will get deleted and the array will get shrinked. So you need to determine the maximum possible amount of money you can win if you go first. And let's say this array. So if I took this array, I'm the one who is playing first, so I have to select either from 5 or 10, that is the first or the last element. I will take 10 because it's the greatest. Then the array will get shrinked and we would be left with 5, 3, 7. The opponent will take either 5 or 7. He will take 7 because it's greatest. I would be left with 5 and 3. I will take 5 because it's the greatest. So the answer would be 15. So let me explain with C++ code and I will clear most of the doubt. So let's say array size is n and we'll declare 2D vector, or I should say 2D matrix with long value, because we don't know its integer value or like what, because it's anyhow gonna be very large. It can be very large. So we'll create a DP table with n columns and each n column would be having n row and all are initialized as 0. So we'll create DP n cross n. So let's say if n is 3, then 0 0 0 0 0 0 0 0 0, all values are 0. So we'll get all the DP value, that is array of DP of 0 0, DP of 1 1, DP of 2 2, DP of 2 1, like that, and we'll fill all the values. Instead of 0, we'll replace it. So we'll take some base conditions. So like if there is only a single coin, then we'll iterate from I equal to 0 till I is less than n and I plus plus, and it will get DP of I and I. So thing to notice, it will take DP of 0 0 1 1 and 2 2 3 3 4 4, like that. That is array of I, the element itself. And if there are two elements initially, then we'll take 0 plus I plus 1, that is the next element, and should be less than n, till I plus plus, and we'll put it as DP of I and I plus 1, and it should be maximum among both, that is array of I and array of I plus 1. So we have already taken case for 1 and 2. Now we'll start with 3. So let me write it, then I will explain what I'm trying to say. int length equal to 3, length should be less than equal to n. So you can see what we are doing here. We are iterating from length 3 till the time length is n, and we'll iterate from the very first element till the last, that is I plus length minus 1. It should be less than n and I plus plus. So what I'm trying to say, so what I did here, I took the entire array, I compared the element like among 5 and 10, then 3 over 5 or 3 7, like that, right? So instead of doing this, if suppose this is a very large element, let's say 20 also, so what I'm trying to say here, we'll compare element, we took the whole array, then we started shrinking it. So we'll start from the very small array sub array, then we'll start making it larger. So initially I took 5, I took length as 3, right? So the element would be 5, 3 and 7. And with some logic we'll get the best value among this. Then we'll go forward. We'll take when I will come here, so I equal to 1, so 3, 7, and j will get increased by 1. So this is basically dp of 0 and 2, and this is the best value among dp of 1 and 3. So this will get the values, and then lately we'll be taking the element, I mean the batch of 4, right? And again we'll get the value, some dp value, as I explained here. This is, I believe, dp of 0 and dp of 3. So like that we'll get all the value, and at last we'll get for this, and so we'll compare this and this. So we already got some sort of value from here, so we'll compare the value, and as we got all the dp values here, we'll put it and we'll get the final answer. So that's what I wrote here. I iterated from I equal to 0 till the last element, that is I plus length minus 1, and we'll put j, that is the last element, as I plus length minus 1. So I told that I will put some logic and we'll do a magic. So this is the magic recursion call. So initially if we took the left value, so in this case if we took 5, that is already took 5, then we'll take among the minimum value of I plus 2 or j, dp of I plus 1 and j minus 1. So let's suppose if I took left, I would be left with 3 till 20. So the opponent will take 20. So if I took 5, the opponent will take 20. Then we are supposed to take the minimum value among this, because anyhow maximum he will take. So that's what I wrote, minimum of I plus 2 or j, and like if he took 20, we'll write it this way, or if he took 3, then we'll write another way. So that's what I wrote, I plus 2 or j, or I plus 1 or j minus 1. And same way if we took right, if I took right, then I will put array of j instead of I, and we'll put the same way dp of I plus 1 j minus 1, because I took j and he took I, so it's I plus 1 j minus 1. And again dp of I and j minus 2. And at last we'll write dp of I and j, whatever maximum value we got from this TL and TR, take left and take right. And after doing this, I will write dp of I j, my bad, I already did that. I will just directly return the first element and the last element. dp of 0 and minus 1 is the answer. So if I talk about the time complexity of it, so we are iterating from length from 3 to n, that is almost n, or you should say n minus 2, but it's almost n, and inside it also it's n, so it's n square. And the same way space complexity would be n cross n, that is row into column. Let me try to run it. Let me submit it. Thank you.